This whole section is about a special rule that comes out when you are multiplying these kind of special binomials together. Notice they both have the exact same variable here, and they have the exact same number here. So these binomials are exactly the same, except one has an addition sign and one has a subtraction sign. So let's see what happens when we try to use FOIL to multiply this out. Our first term is m times m. That is m squared. Our outer term is m times negative 8. Our inner term is 8m. So I have negative 8m plus 8m. There is no term between these two. It makes 0. What's left over then, I still have to do my last term. 8 times negative 8, negative 64. So this is why the book says write each product as a binomial, because my answer only has two terms, the m squared, the minus 64. So now the book will ask us to go backwards. They're giving us the binomial and asking us to factor this. And what they mean by factor this is saying, okay, what can I multiply together to get m squared minus 25? Now I know the first term has to be m and m, because m times m is the m squared. Now I also know that these two terms need to multiply, the last ones need to multiply to be negative 25. Now I could use 1 and 25, or I could use 5 and 5, but what I also know is that I'm missing that middle term. This is the difference of perfect squares. So if I'm missing that middle term, I know these two have to be the same number as well. Only one is separated by an addition sign, and one is separated by the subtraction sign. If I multiply this out, I will get this. Can we use the difference of perfect squares rule here? You betcha. First of all, I'm going to check that there's two terms. There's a subtraction sign. Now both of these terms have to be perfect squares. So let's check. 49a squared is 7a squared. Minus 36b squared is 6b squared. Now I can jump right to the rule and say, okay, here are my two factors. This one's going to have 7a here, 7a here, 6b, 6b, put a plus sign here, a minus sign here. That's my final answer. This one looks a little bit different. First of all, I have my variable on the right side, and this term is only a 1. So let's check if we can use the difference of perfect squares rule. So first thing, I need two terms. I got them. A subtraction sign in between. That works. Now, are these two terms perfect squares? Well, 1 is actually always a square. 1 squared is 1, so we're good there. Now, is this a perfect square? 100 is, that's 10. And r squared is as well. So we could rewrite this like this. Now, difference of perfect squares rule says 1 goes first, 10r goes next. I'm going to put an addition sign here and a subtraction sign here, and I'm done. That is factorable with the difference of perfect squares rule. Okay, let's talk about what happens if the variable is not just to the second power, but it's a little bit different. This one's to the fourth power. Now, in order to use difference of perfect squares rule, I need two terms, and I need a subtraction sign. So far it seems like it's meeting our criteria for using perfect squares rule. And I will tell you that actually both of these are perfect squares. 81 is 9 squared, and c to the fourth is actually c squared squared. As long as this is an even power, you will be able to write this in this way. So now I can go ahead and use my difference of perfect squares rule. I'm going to draw my two terms. I'm going to put 9 first. C squared is second term. Here they're being added. Here they're being subtracted. Now in most cases, I'm done at this step. However, this guy right here, That is another example of the difference of perfect squares rule. 9 is 3 squared, and c squared was obviously c squared. So I can factor this part into another set of binomial terms. 3 here, c, addition sign, subtraction sign. So this part, just this part right here, gets factored to be this right here. So now if I'm looking at writing a final answer down for this problem, I'm going to write, here's the first set of terms when I factored. Then we changed the 9 minus c squared to be 3 plus c, 3 minus c. So this is an example where you have to use difference of perfect squares more than once.